Welcome back to chapter 6. Today I am going to discuss about weights. Before I explain about weights, different types of weights, I will discuss the need of weight. There are two different types of needs. Okay, first thing is, I'm going to run this test case and show you. Yeah, did you see that test case is done pretty fast and we were not able to see the action. So what happens in this case? We need to go and delay it. Okay, we need to wait. So for that, I am going to click here, F12. Okay, here I'm going to write a wait. So after going to the URL and maximize, then I'm going to type system dot threading dot thread dot sleep. So if you see here, you can wait using milliseconds. Okay, so I'm going to type 5000. 5000 means 5 milliseconds, which is equal to 5 seconds, which means it will wait for 5 seconds. Okay, I'm going to run the test now. I'll put it side by side so that you can see. It launched the browser, it maximized, and it waited for 5 seconds. 1, 2, 3, 4, 5. Then it entered the user ID, password, and close. So that's the way you use the wait. Okay, you can put the wait here as well. So waited for some time to enter the login. Then after that, it entered the login, waited for another 5 seconds and close the browser. Okay, so this is how wait has been used. Okay, we put the wait after the submit. So we waited after logging in, waited for 5 seconds, then close the browser. That's what you're seeing. So this is one way of using the wait, basically to slow down the speed. But you may wonder why you need to slow down the speed. Okay, there are instances in which when you load a web page, some of the elements are sluggish in nature. In the sense, some of the web elements are slow in action. Okay, today the website what we have is basically we don't have any sluggish element, but in the actual situation, in a practical world, some of the web elements, example, some login button or some user text boxes or some tabs or some drop down menus or some checkboxes, that might take some time to load on the web page, load in the DOM. Okay, in the document object model, that's called as DOM. So at that time, we actually need to wait until the whole element is loaded onto the page. I'll tell you a typical example. In a scenario, take a scenario of a meeting. So in a meeting, everybody is supposed to come on time, but there are situations in which some of the members in the team won't be present. So what we'll do normally, we'll wait for that person, maybe important person like a boss or someone who is conducting the meeting. We'll wait for him. So we'll wait for a specific time interval, let's say 5 minutes. Then we will start conducting the meeting. So same way in web world, in web pages also, there are some elements which are sluggish in nature or it will come late. So we'll wait for him then until it's loaded. If we don't wait, what will happen is it will throw an exception. Okay, stating that that specific web element is not found. Okay, so that is the actual practical scenario in the real-time world, in the corporate scenario that you will be using this system.threading.thread.sleep. It will sleep ideally, okay? But the scenario is, how do we know that we need to wait for 5 seconds? Okay, if you are working in a company, you know how long you are very expert in that specific website or some web application. So you'll know what kind of elements requires the time. Some of the elements requires 5 seconds, some of them 10 seconds. Over experience, you will be able to do that. So in that sense, the thread.sleep is a nice way of doing it. But not always this is true. Okay, there are cases in which some elements, the same element might take sometimes 4 seconds, sometimes 3 seconds, and then some more than that, depending on various situations, the load on the server, the internet speed, and various other stuffs. So there you might have to use an implicit wait. This wait, what you see here, is basically called as a forced way of stopping. It is just sleep. The program will sleep for 5 seconds. Instead, you call it 500 milliseconds. Then it will execute. Okay. So one way, as I said, you know by practice you'll know which one to use. But other way of using is implicit wait. What you're seeing, this is kind of a forced way of waiting. Another way is called implicit wait. So we are going to implement an implicit wait. So okay, I'll take another code. Another method I'm going to construct. I'm going to write it as implicit wait. So implicit syntax is, I'm going to write it down here. Driver dot manage dot timeouts dot implicit wait equal time span. See, if you click in, you will get everything there, right there, from milliseconds. You can choose milliseconds, minutes, seconds, depending on. I prefer milliseconds. That way it will be much easier. And I have to give a value. I would give a value of, let's say, 1000 millisecond. Okay, 5000 milliseconds means 1 second. Okay, what does this mean? This means it will wait for 1000 seconds, so 1000 milliseconds as a whole. But after 1000 milliseconds, it will throw timeout and it will throw error. It's showing that unable to load web pages. Okay, let's put a little bit more higher, 5000. So what does we do here basically is the concept of polling. I would say an example of polling is, imagine that you're traveling from a location from A to location B. If you know the timing to reach B, say about 1 hour, okay, you start from point A. If you know after 1 hour, and you just look at your watch and see after 1 hour you reach destination B. So that will be equivalent of your forceful wait. Okay, after 1 hour you reach, and you look at the watch after 1 hour and see that you reach the destination. But there are situations we don't know the time between A and B. So that time what you will do, you'll do a kind of a polling. Polling is equivalent to, okay, after 15 minutes, you'll just look through the window of, let's say, imagine that you're traveling in a bus. You will keep polling. Okay, am I reach the destination B? No. If not, you will continue again. Again, after 15 minutes, we'll look outside and see whether we reach the destination B. And you keep on doing this until you reach the destination. So this is a kind of polling, and the same concept is being implemented in implicit ways, what you see here. Okay, so in that sense, if the web element is available within the first 1 millisecond, fine. I don't need to wait whole 5000 millisecond. And it keep on polling. Ideally, let's say it will internally, Selenium will take a 200 millisecond. It will go 200 millisecond and check whether that web element is element or not, or whole web elements in a whole DOM is available or not. If not, it will throw another 250 until it reaches 5000 milliseconds. But what will happen after 5000 milliseconds means after 5 seconds, even if the web elements are not available after 5 milliseconds, sorry, 5000 milliseconds, then it will throw in error. Then you can report the issue. Something gone wrong. There is a performance issue because it's taking more time. So you can inform your developers to fix the bug. So this is a simple concept of understanding between an explicit wait and implicit wait. Implicit wait is implicitly we are mentioning. Example is the polling example which I said. Explicit wait, something we can say the way of forcefully making it to wait, but for that we have a precondition that okay, at least 5 milliseconds it will be available. So this is what I have used it here. So let's try to implement, try to do that as well. Call this function, call as implicit wait from here. I normally do implicit wait in the beginning of the code. Normally it should be used globally across all test cases to check all web elements, the whole web elements are available in the document object model of the website. Okay. So where's my implicit wait? Okay, right here. Driver. Okay. I'm going to run this. So that's a way these two weights works. Weights are very important, and there will be a lot of other algorithms that can use to implement weights. And thank you very much. Thanks for watching our video. Hit the subscriber button for more videos.